All right, so this is the final screencast in Chapter 2. You've seen many relationships between angles and sides, and so we're going to finish up here with triangle sum and the properties of special triangles. Let's start out then with the isosceles triangle, which we talked a little bit about. It was in one of the examples we did in one of the previous sections. If I were to draw it out here, let me again get on my pen. What do we know about an isosceles triangle? Well, we know that an isosceles triangle has two sides that are of equal length. So let's call this triangle A, B, C. And for the isosceles triangle, we would have side AB is equal to side BC. And the hash marks here give us the indication that the sides are the same. In addition, we know that the side opposite angle A is lowercase a, and the side opposite angle C is lowercase c. Well, there is a relationship between the side and the angle opposite. Therefore, angle A right here must be equal to angle C, because they're opposite sides. Lowercase c and lowercase a are of the same length. So again, the base angles in an isosceles triangle are congruent, and the base angles are the angles opposite the congruent sides. Let's take a look at triangle angle sum. So if we drew a triangle, and again, I struggle with getting onto the pen. Now we're onto the pen. Let's do an obtuse triangle like this. And we're trying to figure out the angle measure for B, A, and C. Well, one thing that we should know, or that you may know already, is that A plus B plus C needs to equal what? What's that? Yes, that's right, 180 degrees. So here it is in writing. All angles in a triangle add up to 180 degrees. We can now look at a few examples and figure out how to find some angle measures using some of the stuff we already know or that we've already learned in Chapter 2. Here we have example 1 where we're asked to find angle Z. So here's Z, and again, from what we've just learned, we know that angle X plus angle Y plus angle Z must equal 180 degrees. So now we can fill in. Angle X we know is 41 degrees from right here. We know Y is 123 degrees right here. And Z we're trying to find. So using our strong algebra skills, we can figure out what angle Z is. 41 and 123, we want to get Z by itself. So 41 and 123 would give us 164 plus Z is equal to 180. And then we want to subtract 164 from each side. And then we would get, let me move this up just a little bit. We get Z is equal to 16. So 16 degrees. We can fill that in right over here. So incidentally, if we move back up, or move this down, and we take a look at the triangle, what this will now show us is that the side opposite angle Z, again, is lowercase z, and the side opposite angle X is lowercase x, and the side opposite angle Y is lowercase y. But now we know what the longest side has to be. The longest side has to be y because it's the side opposite the largest angle. So that would be your largest side. Tell me what the next largest side would be. That's correct. It'd be side x, because the angle length is 41 degrees, which is greater than 16 degrees. And then the smallest side would be, that's right, z. So again, seeing these relationships between angles and sides, in addition to understanding that the sum of the angles of a triangle add up to 180 degrees. Example 2 here, we're going to find the missing angle, which is angle x. This is when it gets a little exciting. And you can start to piece together a puzzle. Because there are certain things that we know about a triangle. There are certain things that we know about supplementary angles. Angles that add up to what? That's right, 180 degrees. We know something about complementary angles. Those are angles that add up to 90 degrees. So we can use a lot of what we've already learned in Chapter 2 to figure out what angle x would be. So it may be easier to label these missing angles inside the triangle. So we might want to call this angle y. We want to call this maybe angle z, just to help us out as we go through the calculations. Probably want to start over here. There's a reason why we've been given 125 degrees, and there is a relationship between 125 degrees and this angle y. 125 degrees plus y has to equal, that's right, 180 degrees, because they are supplementary angles. We can now solve for y by getting y by itself. We want to subtract 125 degrees from both sides, and that will leave us with y equals 55 degrees. And again, the reason why we started here is because if we got another angle inside the triangle, like y, we would then know that there's a relationship between the angles inside the triangle. So that's 55 degrees, and we can find z because we know the angles of a triangle must add up to, that's correct, 180 degrees. So let me slide that over, and let's focus on the inside of the triangle, where we know that y plus 15 plus z has to equal 180 degrees. So let me move this up. We know what y is. We just found it. It's 55 degrees. So 55 plus 15 degrees plus z equals 180 degrees. And again, we labeled the triangle y and z. You could have labeled it a and b. You could have used any letter. Let's now solve for z. So we need to get z by itself. So we need to add 15, and 55 and 15 would be 70. So 70 degrees plus z is equal to 180 degrees. And again, I'll move this up slightly. And we'll subtract 70 degrees from both sides, which will leave us with z is equal to 110 degrees. So I'm going to take and put in, 110 degrees over here for z. And then finally, we can solve for x. And I'll box this in over here. We do know that there is a relationship between angle z and angle x. And the relationship is that they are supplementary. So z plus x is equal to 180 degrees. And in this situation, z is 110 degrees. We're trying to find out what x is. And we know that if you add the two of them together, they have to equal 180. So we can subtract 110 from both sides to get x by itself. and we could then get x is equal to 70 degrees. So we were able to find the missing angle by using what we've learned in Chapter 2, starting with supplementary angles and knowing that they add up to 180 degrees, using what we've learned in this chapter, which is the sum of the angles of a triangle add up to 180 degrees, which allowed us to solve for angle x. That's right, it's time once again for our section on try these. So, if you've done a nice job of looking through the screencast, you'll now arrive at some problems that you're going to try on your own and show to your teacher that you have actually watched this screencast. So, looking at the diagram, you're asked to find the missing angle. You should notice here that we do have a triangle. We may have some supplementary angles as well. So just like we did in the previous example, you should be able to go through this and find angle x. Best of luck. Here in problem 2, looks a little bit more difficult because it seems as if you're not given enough information. But keep in mind that we do have hash marks, and you should probably take it from the standpoint that you're looking at two different triangles. Okay? You have to understand what the hash marks mean, and you should be able to put this puzzle together and solve for angle x. Once again, good luck. Alright, so here example, or problem 3, and this is for the real pros. This is more of an extra credit type problem. Again, some of this takes into account your algebra skills, but again, don't be fearful of the variables here. You have to stick to your guns and trust the fact that you know that the sum of the angles of a triangle add up to 180 degrees, and the sum of two supplementary angles adds up to 180 degrees. So here we're asking you to solve for x. Good luck.